We are going to practice more about determining the formation of ionic and covalent bonding. Okay, from the previous video, we know that the ionic bonding is actually the bonding between metal and non-metal. Covalent bonding is actually bonding between metal. Sorry. I repeat again. Ionic is between metal and non-metal, where while the covalent bonding is between non-metals and non-metals. And then I also showed you the which on the periodic table is actually metal and which part is actually non-metal. So let's just quick in here. Water, is it covalent bonding or ionic bonding? I will give you 3 seconds. Yeah, time is up. So hydrogen, of course, is non-metal. So this is non-metal. This is non-metal. Oxygen, of course, non-metal also. So you're going to expect this is non-metal and non-metal. So hence we are going to expect this is going to be covalent. Covalent bonding. Carbon dioxide. Carbon is non-metal. It's like the one that is in your pencil. Oxygen, another example of non-metal. So this is going to be also covalent bonding. Covalent bonding. How about the CaCl2? Okay, I'm going to wait for you to search in the. You can pause the video. What is the calcium? What is the location of calcium in the periodic table? Calcium. Quick. Yeah, time's up. Calcium is in the group two, so it's gonna be metal. So it's gonna be metal. Chlorine is non-metal, so it's gonna be ionic bonding. Sorry, ionic bonding. Okay, now we're going to prove that there is sharing electron in the water and then sharing electron in the carbon dioxide and then give and gaining electron in calcium chloride. Calcium dichloride. This is wrong. Calcium chloride. Okay, now let's take a look at water. So we start with the configuration of electron. Water is 1 and 1. Of course, it's going to have 1 electrons only, so it's gonna be needing one more electron, need one electron, and then oxygen, if you take a look at the periodic table, it's gonna be 16. Oh, sorry, it's gonna be 8 and 16. So 8 will be 2 and 6. So as you can see in here, the 6 in here indicating it needs 2 more electron to become 8. Remember octet rule. So it's gonna be need 2 electrons. So this is need 1 electron. This is 2 electron. How to then how can we accommodate all of that? So we are going to use dot and cross again in here, you guys. Dot and cross is very easy. First, you have to take a look at the composition of atom H2O. We can consider oxygen is center of atom. What is center of atom? Well, simply we can say center of atom will be the least number of atom in the molecule. Molecule of water contain 2 electron of hydrogen atoms and 1 of atoms of oxygen. So oxygen only 1, so oxygen will be um, in center of atom will be surrounded by two hydrogen, as you can see H2O. So you go hydrogen, and maybe you can put in here also. Okay, so hydrogen we call it surrounded atom. So start with the surrounded atom. Surrounded atom will be having 1 electron each because of this 1 electron. So you go 1 electron each, and then now we have to make each of hydrogen need 1 electron. Okay, so need 1 electron. Where is the electron coming from? Of course, from oxygen. So give 1 electron from oxygen. It's not give, it is share. In here we represent the electron of oxygen by dot. So this is also from oxygen. Since electron has 6 electrons, so the remaining after sharing 2 electron, oxygen has 4 other. I repeat again, since oxygen already shared 2 electron to hydrogen, I mean 1 electron each because you have 2 hydrogen. So the remaining out of 6 electron, these 2 you can ignore, yeah, because remember the dot and cross only represent the outermost layer. So oxygen gonna have 4 other remaining electrons. So 1, 2, 3, and 4. Okay, now let's draw the ownership line. So, well, because this is sharing of electron, this cross electron will also owned by oxygen. So you can draw the oxygen has all of it. Okay. So let's count whether this is it or not. One, two, three, four, five, six, six, seven, and eight. So one, two, three, four, five, six, seven, oh, eight. So it's gonna be octet already. And then the hydrogen, each of them will also have these electron and these electrons. So take a look at this one. Let me give you like another color. So, okay, in here you can see that this over here is the it's like Venn diagram when this one pair electron is actually owned together. So it's shared electron. So this is shared electrons. This also shared electron. Because of these shared electrons, both hydrogen and oxygen, both of them know stable. Hydrogen is in a duplet because it has two electrons, and then oxygen is in an octet because it has eight electrons. I think that's clear. Let's move on to carbon dioxide. Again, carbon, take a look at the periodic table. It's gonna have 4, 6, so it's gonna be 2, or I'm sorry, 6 and 12. Let me uh, erase this and then like really uh, okay. So okay, oopsie. So carbon is 6 and 12. So 6 will be 2.4, the configuration of electron. And oxygen, the same, yeah, 8 and 16. So it's going to be 2 and 6. Take a look at this one. So this gonna need 2 more electron. Sorry, 4 more electron become 8, yeah, 4 more electrons, and then oxygen will need 2 more electrons. So how can we do that? Again, take a look at CO2. What is the center of atom? Of course, carbon. I repeat again, the center of atom is actually the least number of atom in the molecule. This is 2, this is 1. Of course, you're going to expect carbon in the middle, and then there is oxygen, and then there is oxygen. Okay? Now, let's start always with the surrounding atom. Okay, so let's start with surrounding atom. You will have oxygen. Oxygen has 6 electron valence, so you go 1, 2, 3, 4, 5, 6. In here also 1, 2, 3, 4, 5, 6. And then as you can see in here, each of oxygen need 2 more electrons. So you're going to take the electrons from carbon, of course. So you go, this is electron from carbon, and then this is electron from carbon as well. Now, if you can see in here, well, the oxygen is already octet because it's going to be 1, 2, 3, 4, 5, 6, 7, 8. It's already octet. But the carbon is only have, it's now still have 4 electron. It's need 4 electron more. So what can you do? Well, now it's time for the oxygens to also what we call it, share the electrons. So erase those 2 electron each of the from the oxygens. So if this is going to be erased also. So and then move it as a shared electron. What the meaning by that? Well, the meaning by that is you then have to put, wait, sorry. So those cross will be put over here and then move over here. So it previously down here, right? Down here. So now you move it there. So by doing that, you basically saying that, well, the oxygen also shares 2 of its own electron, right? So now if you then draw the ownership, so now because those 2 electron from oxygen also shared, this is the ownership of electron in the carbon. If you count the electron inside it, it's going to be 8. And the oxygen will be this. Okay, will be this. Okay, now the number of electrons shared will be shown here. So this is the shared electron, and this is going to be also shared electron. Okay, so I'm going to give you a little bit more in here. Um, every one pair of shared electron, I repeat again, every one pair of shared electron will be forming a bonding, one bonding. So from water, it's going to be one bonding representing this pair of electron, oxygen, and then one bonding hydrogen, and then this is going to be the what we call it lone pair, the electron in the center of atom that is not used in the bonding. While in the CO2, this is carbon, because there are two pairs, so you go double bond of carbon oxygen. This is also two pairs or four electrons, so we're going to have double bond as well. Double bond covalent bonding. Now, let's take a look at, hopefully you understand, calcium chloride. So uh, calcium, I forget the number, atomic number of calcium. What is the atomic number of calcium again? Wait, guys. I forgot. Oh, 20. It's gonna be 20. So it's 20 and 40. It's gonna be 2.8. It's already 10, and then 8, and then 2. Well, if you kind of like, you found difficulties in making the configuration of electrons, remember you always can generate the what we call it electron valence in here by seeing the group of calcium. Calcium is in a group 2, so the electron valence must be 2. Maybe I can make later on the more comprehensive video about the configuration electron. For now, let's just continue. The chlorine is 17 and 35, and then from 17 we then go 2 and then 8 and 7. So in here, calcium either can gain 6 electron or just give up 2 electron. Of course, the simplest way is give up these 2 electron. So you go calcium, and then to become releasing 2 electron, because releasing 2 electrons become 2 positive. And then chlorine will have accepting 1 electron, and then it's become chlorine minus. It's in the previous video, the chlorine, yeah. So as you can see in here, there are 2 electron given, but every chlorine, each chlorine only able to accept 1. So we need 2 chlorine. That's why it's CaCl2. Why we need 2 chlorine? Yeah, because chlorine has to accept 2 electrons from each calcium. So that's why it's need 2 chlorine. So what will happen in here is you have 2 chlorine and then 2 electron and then 2 Cl minus. So the bonding will be, of course, between the Ca2 plus ion and 2 Cl minus. So you go Ca2 plus and then 2 Cl minus. So this is the bonding. There is no need of dot and cross diagram because, yeah, basically they just like that. Okay, that's all. See you on the next video. Bye, guys.